All right, so continue with integration by parts. The choice of u again is choose the simplest function first in the sense, well, in the sense that its derivative is simpler, right? And again, Liate has been our guiding direction there, log, inverse, trig, algebraic. So far we've been able to deal with one of those three type functions, but in this example it has exponential and trig, only the bottom two choices, which are the worst two choices here. Really, it doesn't really matter the order, both are about equally bad. I'm going to choose in this case u to be cosine of x. Now you can see I've entitled this going in circles, and you'll see kind of what we mean here. So if u is cosine of x, then dv is just e to the x. So what is the derivative of cosine of x? That is negative sine of x, right? And here we have v is what? Antiderivative e to the x, integrating is e to the x. So pretty simple there. Okay, and so the integral of u dv, all right, u is cosine of x, dv is e to the x dx, is uv, so that's cosine of x times e to the x. I'll just multiply them this way. I've got vu instead of uv, doesn't really matter, minus the integral of v e to the x du. Notice du is negative sine dx. Well, let's just go and write that v du. But this negative comes out and it becomes positive, right? Now, e to the x sine of x is the integral we have to do. Has the integral that we started with gotten any better? Really, no. I've just swapped the cosine x for a sine of x. It hasn't gotten any better. Okay. So you might say, well, the previous example, last video, we tried integration by parts again. Maybe if we try it again, it will work. Well, let's see. Let's look at this. Now I can choose my u to be the trig function again, sine of x. So that du, the derivative of sine of x, is just cosine of x dx. My dv is e to the x dx. Antiderivative is, again, just e to the x. And so I'm going to write this from the beginning. The original integral, e to the x cosine x dx, is equal to e to the x cosine of x, so don't forget that part, plus, and then I have uv, so sine x times e to the x is e to the x sine of x, minus the integral v e to the x du cosine of x, so just integral e to the x cosine of x dx. All right, so where are we? Well, lo and behold, here was what we started with. We're right back where we started from. Hence the name going in circles. And yeah, so we're not going to get anywhere, right? Integration by parts doesn't seem to be helping because we're right back. We can't ever evaluate this integral. But I'm going to say we don't need to do that. And the reason is I have an equation essentially in the unknown, which is this integral. If I just call this whole thing that I'm looking for, e to the x cosine x dx, if I just call that I for integral, I'm looking for that integral, then this also is I, right? And what do I have? I equals this plus this minus I. Can you solve the equation for I? I is not really a variable. It's a function, really. It's a function. And yeah, add I to both sides. I get 2I is what? What's left? E to the x cosine x plus e to the x sine x. And then I get what? Solve for I by what? Multiplying by a half or dividing by 2. I'm going to multiply by half. And there's my answer. Of course, I want to do what to the very end? When I'm all done, I need to include what? Do you remember? Plus what? C, right? When we're all done. But there it is, right? So this is the antiderivative of e to the x times cosine of x. There's the antiderivative of e to the x times cosine of x. And so the thing is, if you have a integral involving exponential and trig functions, it may be that you can use integration by parts a little bit differently. In other words, if you use integration by parts 2 or more times and you get back to the original integral, you're typically going to have an equation in which you can solve for the integral. Okay, so in many ways, well, this can work in certain settings. Okay, so you're going to see some of those in the homework, and you want to practice those. All right. So much for going in circles. Hopefully your head's not spinning too much on that one. So you want to look back through that one. Okay. Let's take a look at something sort of different. Okay. We're going to start our transitioning in the next set of videos, lectures, into the integrals involving trig functions. And one of the main ones that we have problems with is the antiderivative of sine squared x or sine cubed x or sine to the fourth x and so on. In general, sine and sine to the nth power. What's the antiderivative? Well, be careful. You just can't. Please know that the antiderivative of sine squared x is not cosine squared x or negative cosine squared x. Right? Please. Right? The antiderivative of sine of x is negative cosine of x. The antiderivative of sine squared x is not just negative cosine squared x or positive cosine squared x. But this is a formula for finding powers of sine, the antiderivative for powers of sine. And it's a, no pun intended, powerful rule. And we call it a reduction formula. The reason is because you're evaluating to the nth power, and you get an integral involving the n minus 2 power. So that's 2 degrees or 2 degrees less. So if it's sine squared here, 2 minus 2 is 0. Sine to the 0 power would just be 1. I would just be integrating 1 here. If it's sine cubed and is 3, 3 minus 2 is 1. I'm just evaluating sine of x. So you see it makes it simpler here. I'm going to prove this formula for you, and I'm going to prove it using integration by parts. But it's going to look a little bit different. So I want to step you through this process. So what I'm going to choose here is I'm going to choose the dv actually first this time. Because all I've got is sine of x. I've got n of them, right? Sine to the nth x is sine of x times itself n times. But I'm going to choose one of these sine of x's because that's the only thing I know how to integrate. The only thing I can integrate is sine of x. I can't integrate sine squared of x yet, sine cubed. Until I get this formula, I can't do that. All right, and I know right away that the antiderivative of sine of x is negative cosine of x. Okay, well, what's that leave the u to be then? Everything else. There's n of these. I take one away. I've got sine to the n minus 1x, right? And again, what's this mean? This means sine of x to the n minus 1 power. Don't forget that's what that notation means. So what's the derivative here? What's the derivative? It's by the chain rule. It's by the chain rule. The n minus 1 comes down to the what power? Subtract 1 from n minus 1 gives me n minus 2. So that's the outer function, right? Derivative u to the n minus 1 is n minus 1 u to the n minus 2 times the derivative of the inner function. What's the derivative of sine of x? Cosine of x. Okay. So this is by the chain rule. So du is this dx. Okay, you might say, oh my gosh, that's a big mess. And you're right. Okay, so what do we get from this then? We can see then the integral of sine nx dx, which is integral u dv, is uv, so u is this, U is that, and V is negative cosine of x. So I'll put the negative sign out here. Okay, and you might look at the formula and say, hey, we already got part of it kind of going there, except what's this thing? Well, we'll look at that here in a minute. So that's UV minus integral V, which is negative cosine of x, du, and du, yeah, is all this long stuff here, n minus 1 sine of x to the n minus 2 cosine of x dx. Okay. Now I'm going to clean this up a little bit, so I've got minus this stuff. I'm going to leave the same, and I've got minus minus is plus, and this n minus 1, that's a constant. N is a constant. N minus 1 is a constant. I'm going to pull that outside. The only thing that's a variable is an x in the integral. And then I've got sine of x to the n minus 2 power times cosine, that's cosine squared x. Okay. All right, so bear with me now. What I'm going to do now might not seem quite right, but maybe after I'm done it will make sense. Do you know the Pythagorean identity? All right, the Pythagorean identity. I hope so. I'm going to make use of it here. Pythagorean identity says what? Cosine squared x plus sine squared x equals 1. If I solve this for cosine squared x, it's what? 1 minus sine squared x. This is 1 minus sine squared x. Now, what I'm going to do now is take this sine of x to the n minus 2 power and distribute it through here. Okay, so let's do that. What's that going to look like? Okay, sine of x to the n minus 2 power times 1 is just sine to the n minus 2 of x, and then minus sine x to the n minus 2 times sine squared. You add the exponents. N minus 2 plus 2 is just n. Okay. And now I'm going to split these up. This last integral, I'm going to split it up. So be careful here. I'm going to split it up and distribute this n minus 1 through. So I'm going to get plus n minus 1 times the integral of sine n minus 2x dx, and then minus n minus 1 times the integral of sine nx dx. Okay, and keep in mind that was what this was all from just an integral of sine to the n x dx. But what I want to see is with this choice, by replacing cosine of x with 1 minus sine squared x, I got everything in terms of sine of x here. And when I split this integral, this difference up into the difference of two integrals, and of course distributed this n minus 1 through, what do we lo and behold observe? Our original integral we're looking for is right here. N minus 1 times I. So I can solve for I by adding n minus 1 I to both sides. So here if I have I plus n minus 1 times I equal to what? Well, I'm not going to rewrite it, but everything that's here, right? Because I added n minus 1 I to this side. So all this stuff is added over here. But I plus n minus 1 I is I plus, distribute the I here, ni minus I, which is just ni. So all this stuff over here is ni. So if ni is equal to this stuff, what's I equal to? It's 1 over n times this stuff. So let's distribute 1 over n. It's going to be minus 1 over n sine n minus 1 x cosine x plus n minus 1 times divided by n is n minus 1 over n. So I have to divide both things by n, or multiply both things by 1 over n. Integral of sine n minus 2x dx. And that right there, if you look at it, that is the actual formula that we were given up above. So this is how you find the sine n of x. This is the so-called reduction power, and it's derived using integration by parts. So let's make use of it now and see how this works. Okay. I'm actually going to start. It says sine x, sine cubed x. I'm actually going to start with sine squared x. I'm going to start there. All right. So of course here we know that n equals 2 in that formula. Let me get that formula up so that we can see it. This is not a formula that I would have you have to memorize. Okay, I'm not going to have you memorize that, but you should be able to use it, and that's what I want you to see here. So with n is 2, I just replace n with 2. So I get negative 1/2 sine to the 2 minus 1 is 1, so it's just sine x, cosine x, plus n is 2. 2 minus 1 is 1 over 2, 1/2, integral, and I get sine to the 2 minus 2 to the 0 power. What in the world is that? What's sine to the 0 power? Anything to the 0 power, we're going to consider that to be just 1. So what's the antiderivative of 1 dx? It's just x, right? It's just x. Antiderivative of 1 is x. And so my answer is minus 1/2 sine of x cosine of x plus 1/2 x. And then I'll throw in my plus c. There's the antiderivative of sine squared x. So it's just not, again, cosine squared x or negative cosine squared x. Okay. Now we can rewrite this a little bit differently by using some properties of, or some trig identities. But let's leave it at that. Let's go ahead and look at sine cubed, as the question asked. So sine cubed is going to be n is 3. So again, I'll look at the formula here. It's minus 1 over 3. Sine to the 3 minus 1 is squared x, cosine of x, plus 3 minus 1 is 2 over 3, integral. Now I get what? 3 minus 2 is 1. I just get sine to the first power, or sine of x. And now I can evaluate sine of x because that is negative cosine of x. And so sine cubed is negative 1/3 sine squared x cosine of x minus 2/3 cosine of x plus c. There's the antiderivative of sine cubed x. I want to go ahead and just do one more. I want to do the integral of sine to the 5th power. Here n is 5. Okay, going back to this formula, I'm going to replace n with 5, so it's negative 1/5 sine to the 4th x cosine x. N is 5 minus 1, 4/5. 5 minus 2 is now sine cubed. So when I do all that, I'm going to get negative 1/5. So I said sine to the 4th x cosine of x minus n minus 1, 4 over n 5, integral sine to the, again, n minus 2, n is 5, 5 minus 2 is sine cubed x dx. Now, what about sine cubed x dx? Well, we just found that one, right? That's up here. So what I just need to do is take this and replace it with that. Now, you need to be careful here because I'm distributing through what? A negative 4/5. So you have to distribute that through. Distribute that negative 4/5. So when I do that, I'm going to get negative 1/5 sine to the 4th x cosine of x. Negative 4/5 times negative 1/3 is positive 4/15 sine squared x cosine x, right? That's that term times -4/5. And then this term times -4/5 is positive again. 4/5 times 2/3 is 8/15 cosine x. Wait, something's not right here. I think I've got a sign wrong here. Let me double check what I'm doing here. Oh, duh. That is a plus. My bad. That's a plus. Sorry. So distribute the positive sign through. I had it written out here, and I'm just going along, not even thinking. Sorry, that should be a plus there. I apologize. That was a plus there. It was a plus there. And in the original formula, it was plus. I apologize. That should be a plus. Okay, so I'm distributing the positive 4/5, which is going to make this then -4/15 and minus 8/15 plus C. Okay. I miss having people in the classroom to make corrections for me as I go. I just want to close with this last problem, and that is I want to take a look at a combination. So we've learned integration by parts. Sometimes we use substitution and integration by parts together, we've seen, and that's also illustrated with this problem here. First, we're going to use a substitution. If I try and use a direct integration by parts, I'm going to have a problem because you would choose u to be the x cubed. The dv would be e to the x squared dx. Well, the antiderivative of e to the x squared, yeah, that's one you're going to have trouble with. You're not going to be able to find actually an antiderivative for e to the x squared, not as a finite sum of functions that we know. So we've got to do something else, and that is a substitution. I'm going to use w for my substitution because I don't want to choose u. We're going to see we're going to need integration by parts, so I'm kind of going to use a w instead. And I'm going to choose u to be, or w rather, to be x squared, right, which is inside the e to the u function, right? Now dw is going to be 2x dx, or 1/2 dw equals x dx. But the problem is I've got an x cubed dx. Well, that's okay. So what I'm going to do is I'm going to write this. Let me just write it out here this way. I'm going to write it out this way as x squared e to the x squared, and I've got an x cubed here. What happened to my other x? I'm going to pull it in here with the x dx. So this x cubed, all right, this part here, that is indeed the x cubed. And so what I'm going to do then is I can replace everything. So the x squared is what? That's just the w. X squared is just the w, right? This will be what? E to the w, and x dx is the 1/2 dw. So 1/2 comes out. And there it is. So here's the transformation into the w variable. Okay, it's a little bit better looking, but we're not quite there. Now we use integration by parts. Okay, and we're going to do that with u equal to what? Liate, log, no log, inverse trig, no inverse trig, algebraic, yes, u is just w. And so du is dw. And of course dv is e to the w dw, which means v is e to the w. So usually we don't choose u just to be another variable unless it's in integration by parts. That's one exception. So what do we have by integration by parts? This 1/2, don't forget this 1/2 out here. This integral u dv is u, which is w, times v, which is e to the w, minus, so again this is the uv, minus the integral v, which is e to the w, du, which is just dw. And what's the antiderivative of e to the w? Well, that's easy. That's just e to the w. So by choosing w to be that x squared right up here, we got rid of the problem of trying to find the antiderivative of e to the x squared, which we could not do. But e to the w we can do. And so what am I left with? I got 1/2. Distributing that 1/2 through. Let's distribute that 1/2 through. 1/2 w e to the w minus 1/2 e to the w plus c. But our original integral was in terms of x. That's no problem. I just replaced w with x squared, and I get 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. And there's my antiderivative. So again, we're going to be learning how to combine these different methods that we'll be learning. A lot of times we'll be using multiple methods to find our antiderivative.